Alright, next up we've got the geometric sequence. So the geometric sequence is pretty much the same thing as an arithmetic sequence. Only difference is that we are, instead of using addition, we're going to use multiplication this time. Okay? And we're either going to be multiplying by an integer or we're going to be multiplying by a fraction. Okay? And it's pretty easy, and just like with the arithmetic sequence, the geometric sequence has a formula. A sub n equals a sub 1 r raised to the n minus 1. Now, a sub 1 and n should look kind of familiar. The term position and the first term. Now, the thing that doesn't look very familiar is r. And r is going to represent our common ratio. Okay, that is what we are multiplying by every time. Okay, and it just depends on what we're multiplying by. So it could be 2, 3, 4, 1/2, 1/4, and we'll kind of get to all that as we come to it. So first up, okay, on this first little set, it says to determine whether each sequence appears to be a geometric sequence or not. Okay, if it is, write a geometric sequence equation. Okay, then find the next 3 terms in the sequence. Alright, now this is really not that hard, okay? But if you don't use your calculator, it's going to be exceedingly difficult, okay? So 1 times 3 equals 3. 3 times 3 is 9, times 3 is 27. So yes, this does appear to be a geometric sequence. Now, what we're going to put here is the geometric sequence equation. So that's going to be a sub n equals the a sub 1, which is 1 in this case, times r, which is 3, that's what we're multiplying by every time, raised to the n minus 1. Okay? And that's really super easy. Alright? Now, in order to find the next 3 terms in the sequence, all we got to do is keep on multiplying by 3. So 27 times 3 would be 81. 81 times 3 is going to be 243. And 243 times 3 is 729. Okay? And that's not too bad. Okay? That's pretty easy stuff. All you have to do is just hit that multiply times 3, and it'll just automatically pop out the answer. Now, you don't have to sit there and type in 243 times 3. If you just go ahead and just hit the multiplication button on your calculator, it'll automatically pop up this thing that says ANS, multiplied. That ANS stands for the previous answer, and it'll automatically keep on multiplying for you, which is really cool. So, that's just a nice thing to know how to do. Now, 64 to 16. Now, some of y'all are thinking, that doesn't work. That's not multiplying by something. That's dividing. Mr. Houston, that's dividing. That's not multiplying. We don't have to do that. Yes, we do. We're simply multiplying by a fraction. And we're multiplying by negative 1/4. Okay? And then we multiply by negative 1/4 again. Okay, so yes, this is a geometric sequence. We're multiplying by the same thing every time. Now, in order to get this, we're going to have a sub n equals 64 times negative 1/4 raised to the n minus 1. And that's pretty easy to figure out. Now, 4 times negative 1/4 would produce negative 1. And negative 1 times negative 1/4 would be 1/4. And then 1/4 times negative 1/4 would be negative 1/16. And there's our answers. Very simple. Now, number 3 is going to be plus 5. Ooh, that's an ugly 5. Plus 5. And then we added 5 again. And then we added 5 again. Okay, and if you remember correctly, we're not worried about adding 5. Okay, we're not worried about adding today. That's an arithmetic sequence, so that's a no. A big old no for that one. Number 4. Okay, we multiply by 10. Multiply by 10. So yes, this is a geometric sequence. That's going to be a sub n equals 2 times 10 raised to the n minus 1. Okay, the 2 is where we start. The 10 is what we're multiplying by every time. Now the next 3 terms in this, we're going to do 200 times 10, which is 2,000. Let me make that look more like a 2. 2,000. And then 20,000. And then 200,000. Okay? And each time I'm just multiplying by 10, and all I have to do is just tack on an extra 0. Makes it really simple, okay? Then you have to use the calculator. Pretty nice. Cool trick to know. Alright, now, 2,000 to 1,000, 1,000 to 500. Multiply by 1/2. Multiply by 1/2. Y'all are hoping that that wouldn't come up again. It comes up a lot. So, that's a yes. This is a geometric sequence. And that's a sub n equals, we start off at 2,000. And then our multiplier every time is 1/2. And then we raise it to the n minus 1. Alright, and then the next 3 terms are going to be, let's see, half of 500 is 250. 250 halved is 125. 125 halved is 62.5. And there we have it. Okay? Now number 6. We do minus 1, minus 1, minus 1. That's a no, because we're minusing something each time, and that's not what we're looking to be doing. So, there we go. That's the end of page 1. Woohoo! Alright. Now, up next. Says, given the explicit formula for a geometric sequence, find the term named in the problem. So all we have to do is just take that, whatever term they're telling us to find, and find it. Very simple. So, a sub n, so we're going to go for a sub 5 equals 3 raised to the 5 minus 1. Okay? And that's equivalent to 3 raised to the 4, which is 81. Okay? That's not too horrible. That was actually pretty pleasant. That was nice. So, next one is going to be a sub 6 equals negative 4 times 2 raised to the 6 minus 1. Okay? Now, I want y'all to notice that at no point in time do I multiply this number by that number. Not until the very, very, very end. Okay? After I've already raised 2 to whatever power it is. Okay? Don't forget that. Okay? 2 raised to the 6 minus 1, which is 5. So 2 raised to the 5th. That's 2, 4, 8, 16, 32. 32 times 4 is 128. So negative 128. 28. And there it is. Alright. Now, let's see, what else do we have here? Now we're going to do a sub 8 equals negative 1.1 negative 4 raised to the n minus 1 n minus 1. Okay, n is actually 8, so we can go ahead and erase that and put an 8 there instead. Okay, so we're going to go ahead and shove that into our calculator, and a sub 8 on this one is going to be 18,022.4. And there we have it. Alright. Okay. Last one of these. We got a sub 3 equals 625 on the outside of negative 1/5 raised to the 3 minus 1. So, let's see. Now, 3 minus 1 is 2. 1/5 raised to the second power is going to be 1/25. That's negative 1/25. So, a sub 3 is going to equal negative 25. And there's that. Okay? Now, next up. A table shows a car's value for 3 years after it's purchased. The values form a geometric sequence. Which expression can be used to determine the value of the car after n years? Now, this particular car is decreasing in value every year. So, here's the thing. If we have a number in here, okay, that is greater than 1, that would actually make the value go up every year. So that would be a no for both A and B. Alright, now, let's go ahead and plug in 1 for this right here. So, let's see, 10,000 raised, or 10,000 times 4/5 raised to the 1 minus 1, which is 0. 4/5 raised to the 0 is 1. 10,000 times 1 is 10,000. Okay? I did that without a calculator. You can use a calculator, so use it. Okay? And you would see that that has to be the correct answer. Okay? Now on to number 12. So, a ball is dropped from the top of the bleachers. A table shows the height of each bounce. Find the common ratio, write a geometric equation, and find the height of the ball on the 6th bounce. Okay? Round your answer to the nearest 1/10 of a foot. So, now, y'all are probably wondering, how do I find the ratio on this? Okay? And finding the ratio is really, really, really easy. Okay? All you're going to do is you're going to divide this number right here. You're going to divide this number right here by that number right there. So 196 divided by 280. Put that into your calculator and see what happens. Okay? Whenever you put that in your calculator, you'll find out that that is actually the equivalent of 7/10. So, 7/10 is our common ratio. Now, our equation is going to be A sub n equals 280 on the outside of 7/10 raised to the n minus 1. Okay? Now, we're going to do the last little piece here, and we got to figure out what is it going to do on the 6th bounce. So we go ahead and we load this into the calculator, and we're going to go 280 times 7/10 raised to the 6 minus 1. Okay, if you would like to put in 6 minus 1 is 5, that's fine. By all means, go right ahead. But whenever you do that, you'll find that the answer is 47.1. So it's going to be 47.1 feet. Okay, we can't forget our unit, okay? Your physics teachers will thank us for that later, okay? So, next up, let's see, what else we got? We are going to talk about building houses. So the table shows the number of houses a builder is putting up. Write an equation that models the number of houses being put up a sub n in a specific month, n. Determine the number of houses that will be built after 1 year. Okay, now, first thing that I notice is that it's talking about years and we have months. Okay, 1 year is 12 months. Okay, at least the last time that I checked it was. So, from here, what we can do, okay, we've got to do this number divided by this number, so that's 6 divided by 3, and that is 2, which equals our R. Okay, that's something that we needed to know. So A sub n equals A sub 1 R raised to the n minus 1. So we're going to go A sub 12 equals A sub 1. We started off at 3 houses. And our R is 2. And we're going to raise it to the 12 minus 1 power. So A sub 12 equals, let's see, 2 raised to the 11th power is some ungodly number, and then we multiply that by 3, and that's 6,149. So that is going to be a very, very busy contractor in 1 year. Alright, so, next page. Alright, so we've got number 14 here, and it says that a plant starts with 1 branch. Every year each branch becomes 3 more branches. Okay, a sketch of the plant for the first 3 years is shown below. How many branches will the plant have in 10 years? So, again, we're going to use that A sub n equals A sub 1 on the outside of R raised to the n minus 1. So, let's see, we're going to go with 10 years. So, A sub 10. Okay, we started off with 1 branch. Our R, okay, we're multiplying by 3 each time, so we got 3, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Every year we're multiplying by 3. Okay, and then let's see, it's talking about 10 years down the road, so 10 minus 1. So 10 minus 1 is 9. 3 raised to the 9th power will give us A sub 10 equals 19,683 H. So there we have it. Okay? Let's see. Next up, we got rabbits. Rabbit questions. Duck questions. Rabbit questions. Okay, so given the information from the table below, determine the rabbit population for the following. So first off, we need to come up with our equation. Okay, we're starting off with 10 rabbits. A sub n equals, whoa, that's really ugly. Let me fix that. So we got A sub n equals 10 on, let's see, each time we're multiplying by 3. 10 times 3 is 30. 30 times 3 is 90. 90 times 3 is 270. So we're multiplying by 3 each time. And then we're raising it to the n minus 1, just like always. So now we've got to figure out, well, we're going to do this 2 times. We're going to go 10 times 3 raised to the 7 minus 1. And we're going to go 10 times 3 to the 10 minus 1. Alright? And it's always a good idea to go ahead and lay out your formula first, and then you're done. And then it's so much easier after that. Now, the 10 times 3 to the 7 minus 1, that winds up being 7,290. And then whenever we do it to the 10 minus 1 power, we wind up with 196,830 wabbits. And there we have it. Okay? And that's all. It's pretty simple stuff. Okay? Now, number 16. Okay? It gives us the formula. A sub n equals 2 on the outside of 1/2 raised to the n minus 1. Okay? Create a table and graph to represent this information. So, first off, it gives us n of -2. Okay? So we plug in a -2 in place of n. Whenever we do that, okay, -2 minus 1 is -3. 1/2 raised to the -3 power is going to do something kind of funny. It's going to do something kind of screwy, okay? So just go with it, okay? It's going to become 8. 8 times 2 is 16, okay? -1 minus 1 is -2. And then 1/2 raised to the -2 power is 4. 4 times 2 is 8. Okay? And then 0 minus 1 is -1. 1/2 raised to the -1 power is 2. 2 is 4. And I'm beginning to pick up on a pattern here. 16, 8, 4, 2, 1. And that would probably be 1/2. Okay? Now, you can go ahead and look at that in your calculator and type in each of those into your calculator and see what pops out. Okay? And you're going to see that I was right. So, -2 raised to the 16, or is going to go up to the 16. -1 is going to go up to the 8. 0 is going to go up to the 4. 1 is going to go up to the 2. 2 is going to go up to the 1. And 3 is going to go up to the 1/2. And then all we have left to do is connect our dots. And there we have it. Voila! And it's done. Woo!